AC, or alternating current, is an electric current that reverses its direction in a circuit at regular intervals. An example of alternating waveform is shown in the graph below. This graph is an AC sine wave. The general formula for an AC sine wave is V in terms of t equals d plus a sine 2 pi ft plus theta, where d is the DC offset, a is the amplitude, f is the frequency, and theta is the phase. The basic characteristics of a sine wave are the wavelength, amplitude, frequency, period, peak value, and peak-to-peak value. A wavelength is the distance between successive troughs or crests. This is demonstrated in the diagram below. The amplitude of a sine wave is the maximum voltage measured from the equilibrium, which can be seen in the diagram below. Amplitude is measured in volts. The frequency of a waveform is the number of completed alternations per unit of time of a wave. Frequency is measured in hertz. The period of a wave is the time it takes to complete one cycle. Period is denoted by t. T can also be found by using the formula t equals 1 over the frequency. The period is measured in seconds. The peak value of a waveform is the maximum vertical value measured from zero, as shown in the diagram as VPK. Peak value is measured in volts. The peak-to-peak value of a waveform is found by 2 times the peak value. The general formula for peak-to-peak value is VPP equals 2 VPK. Peak-to-peak value is measured in volts. For the following waveform, find the amplitude, frequency, period, peak value, and peak-to-peak value. We know from slide 2 that amplitude is the A value, therefore A equals 6. Also from slide 2 we saw F was the frequency. As a result, F equals 25 Hz. Now we have the frequency, we can use T equals 1 over F to find the period. As a result, the period equals 0.04 seconds. The peak value for the waveform is the same as the amplitude. For this reason, we can put the peak value equal to 6 volts. Now the peak-to-peak value is just 2 times the peak value. Therefore, the peak-to-peak value equals 12 volts.